Hello learners, I Dr. Niradhar De, faculty member, School of Education, Indira Gandhi National Open University, welcome you all to this video lesson. Today we are going to discuss one of the very pertinent title, that is reliability as a criteria of an effective tool. So friends, presently we are in the 6th week of your online course, that is BES 1 to 7 assessment for learning, and we are presently in 6th module, and title of the module is criteria of a good tool. And in this module you will find 3 video lessons are there. First is self-made and standardized tool, its concept and differences, that already we have discussed in our previous content point. And the present video lesson is reliability as a criteria of an effective tool. So here we will be discussing about the concept of reliability, how reliability is a criteria of an effective tool, and further the another video lesson of this module, of this 6th module, is validity as a criteria of an effective tool. So these are two technical word, you can say reliability and validity. It has its own connotation, it has its own statistical meaning. Okay, so in this lesson we will be discussing about that what does it mean, what is the concept of reliability, and how to establish reliability, okay, of an effective tool. So friends, let us go forward to know that what are the learning outcomes from this video lesson. So friends, after going through this video lesson and at the same time part E content of your module 6, that is criteria of an effective tool, you will be able to list the criteria of an effective tool. What are the different criteria you will be able to list? You will be able to explain the concept of reliability as a criteria of an effective tool, and further you will be able to explain the methods used for establishing reliability of a tool. So now let us go forward to know about that what are the different criteria of a tool is there that we call as an effective tool. First of all, the first criteria is the reliability. A tool, I was just talking earlier in my earlier video lesson that in a standardized tool, the entire procedure of a test development should be followed. Okay, and what are the entire procedure? First of all, writing the items, then analyzing the items, okay, then establishing reliability and validity of the item. So friends, when I talk about reliability and validity, so it means these are the certain criteria of a good tool, and at the same time you see the other criteria of the good tool, just like reliability, then validity, then usability, then objectivity, and the last criteria is the norm. So without developing norm, we can't say that the tool is a standardized tool. But here we are not going to discuss about the norm, we are just going to discuss about one of the criteria, that is reliability of an effective tool, and further in our next video lesson we will be discussing about validity. So now let us focus upon reliability. So to understand about the concept of reliability, we can say that reliability refers to consistency, means a tool or a test that gives us a consistent result always, a faithful result always, a dependable result always, a stable result always, or when we predict this course, when we predict the result of the test, so that also we can say that this is a reliable test. And further we can say that the synonyms that we use for reliability of a test is dependability or stability or predictability. So a test which shows a consistent result in its frequent uses in different situations and places is called reliability of the test. So friends, try to understand first of all when the test will give you a consistent result, okay, a stable result in its frequent uses. Frequent uses means you will use that test many times. Okay, like today you have administered that test, then after 1 month if you again administer that test upon that group of students, and if you will establish, if you find out correlation between two sets of scores in administration and re-administration, you will find that the correlation coefficient will be positive. So that's why in its frequent use at different situations, like today you are using it in Delhi, tomorrow you will use it in Bhubaneswar, use it in Mumbai, and result that you will get, if you will find out the correlation between two sets of scores, then you can say that the coefficient of correlation that you will get, that will be a positive correlation. And further you can use it in different places and in different situations also. And now let us focus upon the methods or the techniques that we follow for determining reliability of a test. So friends, mostly we use three methods for determining reliability. First is test-retest reliability, second is parallel forms reliability, and the third is internal consistency reliability. So here we will discuss about the concept of this method and how to use these three methods: test-retest method, parallel form methods, and internal consistency method. Let us go forward to discuss about these methods. Now let us focus upon the first method, that is the test-retest reliability method. So here you see in the left side you see the conditions are given, and right side its uses are given. Just like in a test-retest method, you see the very term that is used in this method is a test-retest. That means the test will be administered first, and the same test will be administered or re-administered again after a lapse of time, after a gap of time. So that will be the retest. So that's why the very meaning of this method is the test will be administered twice. Testing will be done twice. Okay. So let us try to understand that how to establish reliability coefficient by using the test-retest method. First of all, in this method, a single test will be used, only one test will be used, and a single test will be administered twice. So administration will be happened twice here. So that means the test will first administer upon a group of learners, upon a group of subject, upon a group of students, and the same test will be administered upon that group of students after a gap of time. Okay. So that's why administration will be twice and group will be single. A single group, upon the single group the test will be administered. Okay. So here group will not be changed. And time interval, so far as time interval is concerned, ideally time will be 15 days, the interval will be from 15 days to 6 months. So the retesting or the second administration of the test should not be done before 15 days or after 6 months. Okay. So retesting will be done within the gap of 15 days to 6 months. And further, how to determining reliability? By using correlation coefficient or correlation statistics, by using the correlation method, just like SPEARMAN correlation method or PEARSON correlation method. Okay. But here you see this course when the single test will be administered twice upon the single group of students, then subsequently you will find that two group of scores, because you have administered it twice. Then what you have to do? So after getting two sets of scores, you have to find out the reliability coefficient of these two sets of scores by using either SPEARMAN method or by PEARSON method. And the conditions on the decision of reliability will be, it is reliable if correlation coefficient or R is positive and high. That means R is greater than 0.5. If the coefficient of correlation is 0.5, then you can say that the test that has been developed is a reliable test. And what are the different threats or error so far as the test-retest reliability method is concerned? So here three types of errors are possible. First is carryover effect, and second is memory effect, and third is the practice effect. So try to understand that what is carryover effect, what is memory effect, and what is practice effect. So friends, carryover effect means you will find that when the test will be administered upon first group of learners, that some information of the test, some items of the test, the learners or the subject or the students may remember in a retesting, because the same test will be administered twice upon the same group. So that's why here carryover of the information from testing to retesting is possible. And further memory effect, so here in the first administration, if a student has done something wrong, he or she may do it right in the second administration, okay, because the learners or the subject will practice, and if he or she has done wrong in the administration and further in the second administration, there is the possibility that the learner may do it right, okay. And further practice effect means in case the learners have done it wrong, they can practice it, and they can make it right for the second administration. And here suggestion is, it is very easy to use and determine reliability, but should be the last option for the user to use, because the decisions such like carryover, memory and practice effect are very high here so far as test-retest reliability is concerned. Let us try to understand the methods, the correlation method that you have to use to find out the correlation coefficient or the reliability coefficient of a test when you are using the test-retest method. So here you can use the SPEARMAN method or PEARSON method. In SPEARMAN method, that's called as rho, R-H-O, rho. It is the symbol. So the formula of rho or the SPEARMAN correlation is 1 minus summation 6 into summation of d square upon n into n square minus 1. So here d is R1 minus R2. That means rank 1 minus rank 2. So what you have to do, you have a set of scores. So basing upon the set of scores, you have to find out the rank of the first sets of scores and ranks of the second sets of the scores. Then you have to find out the difference between the ranks. That means rank of the first students in first group, first testing, and the rank of that students in the re-administration or the retesting. Then accordingly that will be the d. You have to find out the d square, then you have to multiply it with 6, then you have to divide it by n into n square minus 1. N is total number of the subject. If it is administered upon 50, then n will be 50. Then accordingly Pearson correlation coefficient, that's called as the R. The formula is R is equal to summation of xy upon n into sigma x into sigma y. Okay. So here x is x, small x is capital X minus m. Okay. Capital X is the individual score and m is the mean. Accordingly y is y minus m. Y is the individual score in the retesting and m is the mean of the retesting. That means in the second group. And n is the total number of the students, okay, and sigma x, that is the standard deviation of the first distribution, sigma y, that is standard deviation of the second distribution. So friends, you all are the adult learner. If you take two sets of scores, then you can find out correlation coefficient, and accordingly you can say that whether the test that you have prepared is a reliable test or not. Then further, in parallel form reliability, it is the second method to determine reliability. In parallel form method, you will find that some of the errors are minimized, but all errors are not minimized. So let us try to understand that what procedures that you have to follow for a standard for using the parallel form reliability. First of all, test, two equivalent forms of test will you have to prepare. So you have to prepare two parallel tests. So that's why the name is parallel form reliability. That means parallel form two tests will be developed, taking from the same content, taking from the same objective areas, same time interval, same types of questions. Okay, but here the items will not be repeated. Items will be different, but everything will be same. And administer. So how many times you have to administer? Here also you have to administer twice. That means in the first administration you have to use the first test, and the second administration you have to use the second test, and group will also single. So that means what you have to do upon a group of students, you have to administer first test, then after a gap of time of 15 days and 6 months, then the second form of test or the equivalent form of the test that you have prepared, you have to use it. So ultimately here you will find two sets of scores. Then by using either Spearman or Pearson's method, you have to find out correlation between two sets of scores. And if correlation coefficient, that is R, is greater than 0.5, then you can say that your test is having reliability. But carryover effect, memory effect and practice effect, though are minimized but not totally controlled. Okay, so definitely it is minimized but totally not controlled. But for such case, what you will do, definitely parallel form is a better method than test-retest method. But carryover effect, that means when the learners will know that in the re-administration similar types of questions you will get, though the questions are not same, but so far as other aspect is concerned, so far as subject, so far as question time and other aspects are concerned, you can say that certain carryover effect is possible, certain memory effect is possible, because learners may carry certain information from the first test to the second test, because content will be same, types of questions will be same. Okay, so that's why practice effect, the learners will prepare themselves to do better in the next test. Then accordingly there is ever scope that the learners may do better in the second form of testing. And suggestion, under suggestion we can say that it is easy to use and determine reliability, but it is difficult to develop exactly two equivalent forms of items. So friends, here the most important task is, it's very difficult to prepare two equivalent form of test, which is equivalent in all respect. Okay, and this is not so easy so far as difficulty value is concerned, so far as nature of content is concerned, so far as coverage of content is concerned, everything will be same, which is not simply possible. And further, now we will discuss about the internal consistency reliability. Here you see in internal consistency reliability, two methods are there. One is the split hub method, then other is the rational equivalence method. So friends, now let us try to understand that what is split hub method and what is rational equivalence method. So friends, split hub method means, you see the term that has been used, split hub. Split means you have to make it two parts, two halves. Okay, and you have to find out the reliability. So how to do it? First of all, under condition you will find that a single test will be used and the test will be administered only once and group will be single upon a single group. So that's why here you see automatically many errors are minimized, because a single test will be used. Here there is no question for using two tests, and it will be administered upon a single group of students. So here group will not change. And third, you can say group will be single and administration will be once. Okay, so that's why here administration is not twice, there are not two groups, we are not using two groups, and here there is no need of providing any time interval, as we are not using two tests, and here we are also not using two administration. Okay, a single administration will be done. So that's why here there is no question for any type of time interval. And for the determining reliability, how to determine the reliability? So here either Spearman or Pearson correlation will be used to find out the correlation coefficient of two half tests. Then after we have to use another statistical formula, the method that is called as split half reliability formula. So here you have to understand that how to use this split half reliability formula. Further we will discuss, and after using the statistical formula, if the reliability coefficient, that's called as the R, is greater than 0.5, then you can say that the test is a reliable test. And here the threat of errors are just like the carryover effect, memory effect and practice effect are minimized, but splitting the full test into two halves is difficult. So here you see carryover effect, carryover practice and memory effect are minimized. It will not work here. But another error it generates, another error it permits, that's called as splitting the full test into two equal halves. That we will further discuss. And suggestion, under suggestion we can say that it is one of the very highly used method, as most of the errors are here minimized. So here you see how to split the two half test, the whole test into two half test. Here you see on this table, the first column is serial number of the subject, that means here the students. The test will be administered upon how many students. So here serial number of the students are there, and further correct scores are there. After administering the test, let the student number 1 has secured 50, student number 2 secured 46, student number 3 secured 55. Okay. Then further what you will do, you have to split these full scores into two equal half. So how to do it? So certain techniques you have to follow. One technique is splitting the whole test into two by using odd items one side and even items other side. And this can also be possible by using other techniques, just like first 50 items, that is from serial number 1 to 50. If total test item in a test is 100, so what you will do, from 1 to 50 serial number item in one side, and from 51 to 100 serial numbers of item in other side. So in this way you can also split the whole test so far as items are concerned into two equal halves. And here as an example, you see subject number 1 had secured 50 score, and here the correct score from odd number item, let it is 29, and correct scores from even number item, let it is 21. Then accordingly in subject 2 or the student 2, total score is 46, from odd item 20 and for even item 26. Then accordingly what you have to do, you have to find out, you have to split the total score into two equal half. So in this way you can just find out two group of scores. So earlier from one group of score, so what you did, you just made it two groups. So here what you have to do, you have to make the whole score into two equal half. Okay, and after doing this, then you have to use the formula. Okay, so that is called as the reliability of the whole test. So how to find out reliability of the whole test? So here what you have to do, Spearman Brown prophecy formula for reliability of full test you have to use. That is also called as that is in split half reliability method. So the formula is RTT, that's called as reliability of the full test, is equal to 2R half upon 1 plus R half. Okay, so here try to understand what is R half. R half is correlation of two half test. You see in our earlier slide, what we have done after getting the after getting the full score of the subjects, you have just split it into two halves, just like 50, that is 29 and 21, 46, that is 20 and 26, 55, that is 28 plus 27. So here we are getting two group of scores. Then after getting two groups of scores, so you have to find out R half. R half means correlation of two half test. So one half test is one side and other half test is other side. And here either by using Spearman or by Pearson, you have to find out a reliability coefficient R. Okay, and after getting R, then you have to use this Spearman Brown prophecy formula to get the reliability of the full test. So that is 2 into R half. That means the coefficient of the two half tests that you have already determined, you have to multiply it by 2, then you have to divide it by 1 plus R half. You have to add 1 with the correlation coefficient of the half test, then you have to divide it, and the coefficient that you will get, if it is greater than 0.5 or if R is greater than 0.5 after applying this formula, then you can say that your test is a reliable test. And further, the another internal consistency method formula that's called as rational equivalence method. So friends, this method rationally you have find out the reliability coefficient, and this is also called as a statistical method, because here you have to follow rigorous statistical analysis. You have to use the rigorous statistical formula to find out the reliability. So just like split half method, here also a single test will be there, test will be only one, administration will be done only once, and group will also one. So that's why here there is no question of giving any time interval, and the errors, carryover effect, memory effect, at the same time practice effect will also not work here, because you are not going for re-administration, you are not going for retesting, okay, and you are also developing only one test. But here it is very much statistically. So internally the formula that you will use for getting the reliability coefficient in rational equivalence method, it is the power of that formula that the formula will determine the reliability, okay. So here for determining the reliability in a rational equivalence method, you can use two methods, that's called as KR20 method and KR21 method, okay. So you may ask question to me that what is KR20 and what is KR21. So KR means it is Coudert and Richardson. Coudert and Richardson are two psychologists. They have developed a formula, and that formula number is 20, okay. So keeping in consideration of the name of the psychologist or the test specialist and the serial number of the formula, it is very much popular, the formula that's called as the KR20 and again KR21 formula. That means Coudert and Richardson have also developed another formula for determining reliability in the rational equivalence method by using rational equivalence method. So that's why these two formula is highly popular to find out reliability. And after using these two formula, either KR20 or KR21, if the reliability coefficient is positive and high, that means if the R is greater than 0.5, then you can say that your test is a reliable test. And here the threat of error, I can say that here there is no question of doing any error, and only error is possible if wrongly you use the formula. If rightly you have used the formula, then here there is no question of doing any error. So that's why in suggestion I can say that this is the best method. It can be used effectively in research in test construction. Now next let us try to understand these two formulas. So Coudert and Richardson formula number 20, that's called as KR20 formula. So here you see the formula is R. R means reliability coefficient is equal to n upon n minus 1. So n is here number of items in the test, okay. If number of items is 50, so here 50 upon 50 minus 1. If number of item is 100, then here 100 upon 100 minus 1. Then into square of the standard deviation minus summation of PQ upon square of the standard deviation. So friends, square of the standard deviation is called as the variance, okay. So that's why here you have to find out, because you have administered the test, then after getting the test you can find out the standard deviation of the test, because you have the set of the score. Then you have to get this square of the standard deviation, so that will be the variance. Then minus summation of P and Q. What is P? P is the proportion of right response and Q is the proportion of wrong response, or that may be 1 minus P, okay. Let you take item number 1. In item number 1, proportion of right response means how many students have made it right, okay. Let 100 students are there to item number 1. Let 60 students have made it right. So that's why you can say 60 by 100, that means 0.6. 0.6 is the P value and Q value is 1 minus P. 1 minus 0.6, that is 0.4. Or you can say proportion of wrong response. That means to question number 1, 40 students have made it wrong. So that's why 40 upon 100. Okay, 40 upon 100, that is 0.4. So accordingly you have to find out P and Q proportion of right response and proportion of wrong response, of all the items. Then you have to find out PQ, that means P into Q. Then you have to add all the values of P and Q. Okay. Then what you have to do, you have to divide it by the variance. So if you try, then definitely you can use it. You can use this formula and you can find out the reliability coefficient by using KR20 formula. And further in KR21 formula, Coulthard and Richardson formula number 21, here you see R is equal to N upon N minus 1 into 1 minus capital M into small n minus capital M divided by N into variance. So here you see variance, that is square of the standard deviation. N is number of items in the test and M is mean of the test score. You have the test score, you have the individual score. So what you have to do, you have to find out the mean. Only two things, you have to find out the mean and you have to find out the standard deviation. Okay. Then after getting standard deviation, you can find out the variance. You can square the standard deviation, you will get the variance. Then you have the variance, you have the number of items, it may be 100, it may be 50 as per your test. Then already you have calculated the mean. So use these values in the formula and definitely you will find the reliability coefficient. And if the reliability coefficient is greater than 0.5 or R is greater than 0.5, then you can say that your test is a reliable test. So friends, just to recapitulate, today we discussed about the concept of reliability. In reliability, how you get a consistent result, a stable result, or you can say a faithful result in its subsequent administration by using different methods. So how to find out, how to establish reliability, we also discussed after understanding the concept of reliability. We have first discussed the test-retest method. It means the test will be administered twice. Then by using correlation coefficient method, either Spearman or Pearson, you have to find out the reliability. If it is greater than 0.5, then you can say that your test is reliable. Then further, you can also use another method that's called as your parallel form method or equivalence form method to find out reliability. And further, you can also use reliability by using the internal consistency method. So by using two further methods or two techniques, you can find out the internal consistency method, that is by split term method and rational equivalence method. Okay, in split term method you have to make the whole test into two equal half by using certain technique, just like odd and even or first 50 and second 50% of the items. And further, in rational equivalence method you have to use two formula that's highly statistical in nature, that is KR20 and KR21 formula, Coulthard and Richardson formula number 20 and Coulthard and Richardson formula number 21. So friends, I think if you practice, then definitely you can understand that the concept of reliability and how to find out reliability in a test by using different methods. For further queries, you can write to me niradhar@ignou.ac.in. You can make me a telephone call. My intercom is 2994. You can visit my Facebook account, my YouTube channel, and my Twitter account, my Twitter handle. You will find hundreds of video lessons are there on different themes on education, on test construction, on your B.Ed program, and definitely that will help you a lot for pursuing your particularly this online course, at the same time your other studies also. Thank you.